Hello friends, welcome to my YouTube channel. I am going to explain about exploratory data analysis in natural language processing. I am going to take Amazon Fine Food Reviews dataset to explain some basic EDA techniques in natural language processing. EDA is very important concept when we are dealing with visualization, data visualization, and understand about the data and feature engineering. So let's get started. I will import pandas, numpy, matplotlib, Seaborn. These modules are very much required to analyze the data, pandas and NumPy to handle the data frames and to do some mathematical calculations using NumPy. And Matplotlib and Seaborn are the data visualization libraries in Python to visualize the data in form of charts. Let me run this. I will create the data frame from the CSV file. And here I am going to take only 1,000 rows of data. It has ID, product ID, user ID, profile name, helpfulness numerator, helpfulness denominator, so many columns, but I don't need all these columns. I need only the text column and score column. So let me filter only those columns. So I have text and score, only these two columns with 100 rows of information. Now, the first thing in EDA, we need to understand what is the type of data set it is. We will see the number of class labels in the score data set. So df of score dot value counts. It will give you the number of labels and the frequency count. And here this is an imbalanced data set. The fifth class label, this is a rating basically 1, 2, 3, 4, 5. The score is nothing but a rating. So 5 rating text comments are 642, and here the lowest rating, that is 2 rating text comments are 47, and in between the remaining comments are available, the frequency, and this is an imbalanced data set. So let me mark it down as an imbalanced data set. This is an imbalanced data set and need to handle using either class weights or resampling techniques while modeling. we are done with the first step of the EDA, and next step will be the cleaning the text data, because the text data will have so many special symbols, or the letters may be in lowercase and uppercase, and there may be some underscores and spaces, and maybe some foreign words, maybe some misspelled words. So these things we need to filter it out, and we need only the text data with filtering all the above things. Now I will write a function to pre-process this text. Get pre-processed text. In this, I will pass the sentence. I import a module called regex. This is a popular module to filter the data, text data. And I will take the sentence. I will replace all the characters other than alphabets and underscore and digits. Other than alphabets, underscore and digits, I will replace everything with spaces. In the next step, I will take the same sentence. Here, I will replace all the digits with spaces. And in the next step, I will replace underscore with space. And next, I will replace multiple spaces with single space. And in the next step, I will convert the complete sentence into lowercase, and I will strip it. So stripping will take care of if any sentence has at the front or rear. If it has some spaces, it will be stripped off. And afterwards, I will use lemmatization, and using the lemmatization, I will get all the root words. So I just called, I will call a function called get lemmatization text, lemmatization text. In this, I will pass sentence. We need to define that get lemmatization text. I will define now, return sentence. Right. So before that, I wanted to define a function called lemmatization text. So df get lemmatization text of sentence. I will use some modules called import NLTK, natural language toolkit, and I also import from NLTK import word tokenize, and also corpus import stop words. I also import from nltk.stem import word net lematizer, and I also import from spell checker import spell checker. In addition to this, I will download Punkt, and I also download stop words. I also download WordNet. Right. So here this word tokenizer, which will be used to tokenize the words, and I will use this stop words library for removing all the stop words, unnecessary words from the text corpus. And this WordNet Lematizer, it will lemmatize the words. It will try to find out the root words. There are any misspelled English words are there in the sentence. I wanted to correct it with this spell checker library. Let's see how we can do this. First, I will initiate English spell checker and language is equal to en. Basically, you can, if you don't use this, language is equal to en also, that's fine. The default is English language only. But if you wanted to use it for another language, then you have to mention that language code here. So I am using English spell checker is equal to spell checker of language en. And once I define this spell checker, then I will initialize the WordNet Lematizer. So Lematizer is equal to WordNet Lematizer. Then I will take the words list from the sentence, from the word tokenize dot word tokenize of sentence. It will give you the words list. It will split the sentence into words by using spaces. And also, I wanted to identify the unknown words from the English dictionary. If you initiate, you have taken this English spell checker, that is the English dictionary. All the words are available, English words are available in this English spell checker. I wanted to identify the words which are not available in the English dictionary, and those words I wanted to correct it. Maybe those words might be a misspelled word, or maybe a technical word too, which might not be available in the English dictionary. We will find out those kind of words also. So I will use unknown words is equal to English spell checker dot unknown of words list. It will give you the unknown words in the words list. Now, what I do, I will iterate over this words list. So for each word in my words list, if word is not in stop words dot words of English language and word length of word is greater than 2, then only I will try to do something. So if word not in stopwords dot word of English language and length of word is greater than 2. Then I will try to see if word in unknown words, unknown words. If word is available in unknown words, then I will try to correct the word using the spell checker. Correct word is equal to English spell checker dot correction of word. If correct word is not none, sometimes it could be a none also because that might be a misspelled word and that might be a technical word which is not available in the dictionary. In such cases, the correct word may come as none. So those that thing also you need to deal with. So correct word is not none. Then I will try to append to a words list. So I will initiate a words list here, corrected words list, an empty list. So for this corrected words list dot append of this correct word. And before appending here, I wanted to find out the root word for it. For that, I will use this WordNet Lemmatizer. So I have the Lemmatizer already. So Lemmatizer dot lemmatize of correct word. Here, once the correct word is found, and if the correct word is not none, then the word will be lemmatized, and that lemmatized word will be added to the correct words list. For example, if the word is not in unknown words, that may be a known word, that may be a perfect English word, then I will directly append it to the correct words list. And while appending, I will use this lemmatizer. Lemmatizer dot lemmatize of word. If the word is none, I just ignore it because there is no use of that word. So I will just ignore it. But if the word is not none, that means the word is corrected. So for that corrected word, I will lemmatize it and I will append it. And uh, uh, if the word is not in unknown words, then I will directly lemmatize it and I will append it. So my corrected word list, now I have my corrected word list completely with right words. I will return by joining these words with space. This corrected list words, I will join with spaces and I will return it. So basically this get lemmatization text, it will return a sentence with correct words, right? So here I call this get lemmatization text here. So get lemmatization of I am passing this sentence, this corrected sentence here, I am passing to here, and from here I am getting the lemmatization. After lemmatization, I am getting the sentence, and I am returning the sentence from this get preprocessed text. Now, and also one more thing I wanted to do here. I wanted to send along with the sentence, I wanted to send the length of the sentence dot split. That means how many number of words are available in the sentence. I wanted to pass that length of that sentence also. Length of the sentence means the number of words available in the sentence. So now my get preprocessed text and get lemmatization text, both methods are defined. Let me run this. The compilation is done. Now I will see this is my data frame which has text and score. I will apply this get preprocessed text on my text column of my data frame. So here from my data frame, I will create another column called preprocessed text, and I will apply on the text column. I will apply this method. This will be faster compared to running a loop. If you run a loop that is not more efficient, it will take more time to iterate over the loop. But if you apply to a series of text, then it will be faster. So that's why I'm going to do here the same thing. So I am trying to apply this function all my text series data. So for each text series data, each sentence will be passed to this get preprocessed text, and here this sentence will be corrected for the alphabets, digits, and underscores, and it will be corrected for spaces. It will be converted to lower case, and it will be get the lemmatization text and the sentence after getting the lemmatized sentence, then it will be passed along with the length of the sentence. Okay, so that will be saved in another column called preprocessed text. So let me, after creating this preprocessed text, let me print the head of the data frame. Let me run this. The NLTK modules were downloaded and I got an error here. We'll see what is the error. Words list corpus reader object has no attribute word. And where is it exactly? There is something word we have used somewhere and it is giving the error. We will correct it. I feel this is the error at stop words. Stop words. Maybe let me look at words. This is words, not word. Let me correct it and run it again and rerun this. Now the stop words are also downloaded and Punkt package is downloaded and the WordNet Lemmatizer is also downloaded from NLTK. It will take a while to process, but compared to the looping over the data frame, complete data frame, applying the function is time efficient. It has a lot of things to do. First, it has to replace these things, and afterwards it has to loop over these words in each sentence, and it has to find out the stop words, and it needs to check the spell checker, and also it needs to do lemmatizer, and it will return it. So there is so much process here, so it will take a while to finish this. All right. It took around 14 minutes 45 seconds to finish this pre-processing, and it also printed the head of the data frame. Here you can see the original text, the score, and a new column is added here. And in the new column, this pre-processed text, comma, the length of the sentence are added. We will see for the first row of text, we will see the sentence, complete sentence. Bought several vitality canned dog food product, found good quality product, good likes to process meat, smell better, have added finicky, appreciates product better. And here the complete row is a tuple. In this, the first sentence is a string, the preprocessed text, and the number, it represents the length of words. Now, I wanted to split this preprocessed text into two columns in the data frame. Let me do that. df of preprocessed text, length of the sentences. My column is df of preprocessed text. I split using str dot split. I use comma, and here I use expand is equal to true, and I print the head. It's shown another columns must be same length as key. Okay, uh, here actually I need to add as type of str, because this is a tuple, it has to be converted into string and then it has to split. Let me run. Okay, now you can see the preprocessed text and the length of sentences are separated. And afterwards, you can see that there are some special characters. And here also there is a closed bracket. So I wanted to remove them. I will remove df of preprocessed text is equal to df of preprocessed text dot replace with some special, with some space, comma, regex is equal to true. And also the same way I follow for length of the sentences, length of the sentence also. In length of sentence, I will remove the special characters there. And afterwards, I will print the head. Okay, here we are. So these special characters are removed and it became length of sentence without any special characters here. Fine. The next step. So now we are done with pre-processing a text and finding the length of the sentences. Now we will find out the unique words in the pre-processed text, the unique word frequency in the pre-processed text. This is very, very important to find unique word frequency in the text. I will create a new data frame called unique, df unique, and I use this df preprocessor dot str dot split, and here I mention that expand is equal to true, and afterwards I will take the stack of this one and I will mention the value counts. This is how you can extract with a single line of code. You can extract a data series unique words, and afterwards I will print the head of df unique. Okay, so here there are some words called chip, like, flavor, taste, good. The chip is repeated 659 times, like is repeated 441 times. Okay, so if you wanted to export this one as an Excel sheet, then you can use dot to Excel, and I just mentioned that unique word frequency dot XLSX, and I mentioned index is equal to true. Let me run this. So here you can see there is an Excel sheet. It is created unique word frequency dot XLSX. I will go to that path and let me open that. So these are the words and this is the count and this is in descending order. I will just copy this and paste it here and just paste special, just paste it. Now I will select everything and I just sort it based on the alphabetical order. Here you can see that the word which has repeated many times from this table, and here from this table you can look at that your alphabetical order words, and here you can see abdominal, able, abraded, absent. So these are the words and how many times this word is repeated. I save this, close this. Now I will find out. So what is the next step? You found out the unique word frequency, how it is useful, this unique word frequency. From this unique word frequency, you can come to know, are there any words, misspelled words? Maybe are there any wrong words are there which are not useful for my model? You can ignore that. And one more thing you can do here is you can find out the low informative words. The low informative words you can find out using TF-IDF vectorizer. So based on the term frequency and inverse document frequency values, you can find out in your text corpus what are the non-informative or less informative words. And those words you can ignore in your modeling. So we will find out how low informative words from sklearn dot feature extraction dot text import tf idf vectorizer, and I also initiate that tf idf vectorizer without using any number of features or any minimum document frequency. I don't define anything. I just initialize the TF vectorizer, TF-IDF vectorizer, and here I will fit this TF-IDF vectorizer with the DF preprocessed text. Let me run this. That is done. Very quick. Now, if you see the features, the feature names are the unique words in your corpus. That one you can get it using get feature names out. And the TF IDF values, you can get it from IDF underscore attribute. So I wanted to combine both. I wanted to prepare a kind of dictionary, unique word dictionary with the TF IDF values. So here, unique word TF IDF dictionary I wanted to create. So just I zip it, the vectorizer dot get feature names out. So it will return the feature names and vectorizer dot idf underscore. So this will have the inverse document frequency numbers. And I will create a dictionary here. Right. I have a dictionary now. And this dictionary I will convert into data frame and I will export to Excel sheet. So pd dot data frame, and I take this dictionary and columns is equal to word or unique word. I just mentioned that unique word, comma, and one more column is TF-IDF value. And here I will export this to Excel sheet as word TF-IDF dot XLSX. So I just keep it in a string. I wanted to create in the current directory and I don't want my index here. Let me run this. Now a word TF-IDF dictionary is exported to Excel. We will look at that. So this one, oh, it is not exported properly. There is something wrong. Let me look at here. What is wrong? Yes, here I need to mention items. Now it works. 72 KB, and let me open this. And here you can see the unique word and TF-IDF values, right? And these are based on the alphabetical order this was given, but I wanted to sort it out based on the TF-IDF values. So here I wanted to sort it based on TF-IDF values from smallest to largest. Now you can see here this like it's a adjective and TF-IDF value is very less here, and this is these values. I just convert this to number format. Just a second. Maybe these decimals, it might be confusing. So I just keep it to two decimals. Yeah. And now you can see clearly. So like TF-IDF value, this is very low informative word. Taste also it's a low informative word. And you can select a threshold value here for TF-IDF value, and based on the threshold value, you can remove the low informative words. So usually I select maybe 3 or 3.5 or 4 as the threshold value, and the words which are less than that threshold value, I will replace with spaces. So that will be improving your model metrics, classification metrics. Let me go to this code here. Now, once you find out the unique word frequency and you found out the low informative words, now you can check for the length of the words. Now our goal is to find out the best maximum length for tokenizing, because the tokenization is very important if you are going for a pre-trained model like BERT. The BERT tokenizer, when you are tokenizing the text, you need to mention that you need to find out the longest word, and it can process up to 512 tokens only. And the BERT is the BERT pre-trained model is very slow if you use the maximum length. And your text corpus, it may not be suitable to use the 512 tokens. So maybe your text corpus, it might be suitable for less than 512 tokens also, because this tokens, max length tokens, it will increase the time taken for the calculation. So by setting the maximum length to the right length from your text corpus, you can ensure that your BET pre-trained model can be solved within less span of time. Now we see what will be the best possible max length for our text corpus. So my next task is finding max length for the text corpus. Okay, now I will just plot a histogram plot from the length of sentences. I have length of sentences in my data frame. I will plot this length of sentences, how they are distributed. I just wanted to know the distribution visually by plotting a histogram plot. So SNS dot hist plot, I use data is equal to data frame and x is equal to length of, I just copy the column name here and I mention KDE is equal to true. Let me run this. Here we are. So this is the distribution of your length of the sentences, and you can see the stats of your length of the sentences. So I just df of length of sentence dot describe. So it has given that the total count is 1000 and unique are 129, and okay, actually this is taking as a string, but I need it as integer. Let me run this. Now you can see that the count is 1000 and mean value is 35.5 and standard deviation is 34 and minimum value is 4 and 25 percentile, 50 percentile, 70 percentile, and maximum length of the tokens. Some of the sentences it has up to 460. So from there are some sentences with 4 words and there are some sentences with 460 words. There is a huge range is available here. And out of this range, what will be the best suitable max length for our text corpus to tokenize our data? We will find out now. I just find my median value here for the length of sentences. Median value of length of the sentences. I will calculate using np dot median of df of length of sentence. And here it is saying some, okay, so here I need to mention that as type str, sorry, integer. Yes, here I need to use an escape character to understand these these strings. Otherwise, I can directly say dot. This also will be a correct way of representation. Now you can see your median value is 25. Your mean value is 35. So I will go ahead with the median value 25 because if you have, I think there are some outliers available in your text corpus and I wanted to go ahead with the median value instead of the mean value. Now I will take the median value is equal to np dot median of length of the sentences and standard deviation value is equal to np dot standard deviation of df dot length of this one. So I just print the median value and standard deviation value. Right. Now I will use this formula to calculate the max length of my tokens. So as per industry standards, how we calculate is we take median value plus some factor. The factor may be 2 or 3 or 4. You need to iterate it and you need to experiment with different factors and how the model is behaving. Whether if you take a factor of 2, then the max length tokens will be different. And if you take token of a factor of 3, then max length tokens are different. Factor of 4, the max length tokens are different. You need to identify which max length is giving the right accuracy for your validation data. So I will calculate 3 max lengths here. So with the first one with 2 as the factor and standard value here, and also I will calculate max length 2 with 3 as the standard value and max length 3 with 4 as the standard value, 4 as the factor, and max length 1, max length 2, and max length 3. I will print. And before that, I will convert into integers because there is a chance of getting float values as max length, but I don't want a float value. I just convert into integers. Okay, here we are. So max length 1 is 93. So you can check with max length as 93 tokens instead of 512 and predict the classification metrics of the model. And you can try with 128 and you can try with 162. Otherwise, if you wanted to use another factor here, you try with another factor and try to get the max length so that you can reduce the dimensionality of your tokenization, and it reduces the complexity of your model, and it improves the classification metrics of your model. So here, how we can use this max length in a BERT model, in the BERT tokenizer. Sorry, from transformers import BERT tokenizer, and I initiate my tokenizer is equal to BERT tokenizer, and I mention BERT base uncased. This is the model I'm going to use. And afterwards, I will encode the data. Encoded data is equal to, I use this tokenizer. And afterwards, I use this DF of pre-processing, DF of pre-processing text. And also I add padding is equal to true. That means if there are some less tokens in the sentence, and it will be adjusted to the max length. And I also use truncation is equal to true. That means here, if you use truncation, if there are some sentences up to 460 words, and those sentences, it will be truncated and it will be fitted to the maximum length whatever you have given. So here, instead of padding true, I use max length, and here I max length I use 93, which we were calculated, and return tensors I will mention here. Okay, so this is how you can encode, you can encode your data. So these are the basic steps in exploratory data analysis in natural language processing. Hope this video is helpful for you to process your data. Thank you for watching, and please like and subscribe if you like this content, and watch my next videos also. Thank you.